Let's look at this procedure again for these two equations. The quadratic, x squared minus 4x plus 3, and the linear 1/2 x plus 1. We want to find their intersection. Now if you go ahead and use your grapher, you'll find that this is one of those cases where you have a parabola and a line that intersects in two different spots. So let's go through the procedure. Set them equal to each other. All right, now I got a fraction, so I'm going to go ahead and clear out my fractions by multiplying through by whatever the common denominator of all my fractions would be. Well, in this case, it's going to be 2. So I'm going to multiply each side of this equation by 2 and distribute it out. So I'm going to have 2x squared minus 8x plus 6 equals x plus 2. All right, now I need to rearrange this equation so that I have a quadratic on the left and 0 on the right, which means I'm going to have to subtract x and subtract 2. So 2x squared, I'm going to subtract x, so that's going to be minus 9x. I'm going to subtract 2, so this is going to be plus 4, and that's going to be equal to 0. All right, now I need to find the roots of this quadratic equation using my quadratic formula. So I've got b is 9, so I'm going to have 9 plus or minus square root of 9 squared, that's 81, minus 4 times a, which is 2, times c, which is 4, and this is all going to be divided by 2 times a, which is 4. So I've got 9 plus or minus. All right, 4 times 2 times 4 is 32. 81 minus 32 is 49. So plus or minus square root of 49 over 4. But square root of 49 is just 7. So this is 9 plus or minus 7 over 4. Well, 9 plus 7 is 16 over 4. But that's just 4. 9 minus 7 is 2 over 4, but that's just 1/2. So there are my two x values of my intersection points, 4 and 1/2. So to get my y's that go with those two x's, I take the x value and put it back in either one of my starting equations. Well, the linear one's a little easier to deal with, so let's use that one. So I'm going to have first 1/2 times 4 plus 1. Well, I'm going to cancel this here. So I end up with 2 plus 1, which is 3. So one of my points, 4, 3. Then I'm going to use the 1/2, put it in here. I've got 1/2 times 1/2 plus 1. Well, 1/2 times 1/2 is just 1/4 plus 1. And 1 is 4/4, so 4/4 plus 1/4 is 5/4. So my other point of intersection, 1/2, 5/4. All right, let's look at another example here. We got a quadratic function, x squared minus 8x plus 19, linear function minus 2x plus 10. If you use your grapher, you're going to see it's this situation where you have this idea of a tangent line that just intersects the parabola at one point. But just looking at the graph, it's real hard to tell that is the case, but because the points could be so close together you can't tell, but in this case that's what it is. So let's go through the procedure, set the two functions equal to each other. X squared minus 8x plus 19 equal to negative 2x plus 10. All right, again, we want to get everything on the left side, so we have a quadratic equal to 0. So I'm going to have to add 2x, subtract 10. So x squared, I'm going to add 2x, so this is going to be negative 6x. I'm going to subtract 10, so this is going to be plus 9 equals 0. So now I need to find the roots of this, but we've got a leading coefficient of 1, so it could possibly be our sum and product rule works. And sure enough, -3 plus -3 is -6. -3 times -3 is 9. So my factors are x minus 3 and x minus 3. This is a perfect square. So that means my roots are both 3. So my roots are 3. So I only have one root to deal with, which means I'm only going to have one point of intersection. So I take my x that I've got now for my intersection point, put it back into either of these original functions. The linear is easier. So -2 times 3 plus 10 is -6 plus 10, which is 4. So my point of intersection, 3, 4.